Okay, let's try to understand and solve question number 6 and 7. Well, this question concerns three concepts: continuity, existence of partial derivatives, and differentiability of functions of several variables. And in this case, two variables. Now, you can see the given function. It equals 0 at origin, that is when both x and y are 0, and it equals xy over x square plus y square at every point other than origin. Now, let's first try to check whether this function is continuous. Before that, for a function to be continuous at a point, here the point in question is the origin, the limits at that point should exist. Since we're dealing with two variables here, we're dealing with a plane. So the limit at the particular point should exist across all different paths, which, along which the points can tend to that point in question here. So let's take any two different paths. The obvious candidates here are along the x and y axis, or let's say x is equal to y line. If the limit at this point is different for any two different paths, then the limit would not exist, and hence it would not be continuous. We'll show that that's the case here. Consider the sequence of points 1 over k, 0. So this represents the sequence of points along the x-axis. As k gets progressively larger, this point tends to origin. So as k tends to infinity, you can see that this point tends to origin, and if you substitute this value in this, you'll see that the limit is 0. Whereas if you consider this sequence of points, that is 1 over k, 1 over k, which is the x is equal to y line, as k tends to infinity, this is a sequence of points which tend to 0. But if you substitute 1 over k for x and the same value for y here, the things will cancel out, and all we're left with is half, which is the value of the limit of this sequence of points at 0, 0. As it is easy to see now that the limits are different. Therefore, the limit does not exist for this function at origin. Consequently, this means that the function is not continuous at 0, 0. Now, let's see whether the partial derivatives exist. Let me first state that continuity at a point is not a necessary condition for the existence of partial derivatives, although it is a necessary condition for differentiability. So if you look at the next question, question number 7, you can easily answer this, that the function is neither continuous nor differentiable. Coming back to the sixth question, we'll see now whether the partial derivatives exist. For that, let's go back to the first principles, that is the definition of partial derivatives. Partial derivative of a function with respect to x at any point a comma b is given by f of a plus h comma k minus f of a comma b over h as the limit of h tends to 0. And this would be same for f derived partially with respect to y at the point a comma b. This will be limit as k tends to 0, f of a comma b plus k minus f of a comma b over k. Now just substitute the values of 0, 0 in these two equations and the value of the function here. You can very easily see that the partial derivatives of this function at the origin will be 0 for both these two partial derivatives, and hence partial derivatives exist even though the function is not continuous at the origin.